Welcome back, everyone. So we've covered things about the periodic table regarding the atomic mass, the atomic number, the number of neutrons, the number of electrons, protons, how to calculate all of those. You've heard me refer to the Bohr-Rutherford diagrams, and we've already done these in class. Remember, this is just a bit of a reminder in case you're having some difficulty with that concept, because I know it could be a little intimidating with all the dots and shells that we're going to be drawing. How do we draw an atom? Now, it is not an exact representation of what an atom really looks like, but it's a good visualization as to the nucleus and the electrons that are around that nucleus. And we call those the Bohr-Rutherford diagrams, and that is after the scientists that studied them. You always start with drawing your nucleus, and that is the center of the atom. That always has the protons and the neutrons inside of them. Then we have what we call shells, and these are the orbits that the electrons travel on around the nucleus. So we have our nucleus over here, and I already demonstrated this in the first diagram, but there's no harm in referring to them again. So we have the central nucleus, and then each of these is called a shell that surrounds the nucleus. We are, for the purpose of this grade, going to only talk about 3 shells around the nucleus. There are more as the elements get larger, but for the sake of the grade 10 science course, we're not going to worry too much about anything beyond 3 shells around the nucleus. There is a rule regarding how many electrons each shell can contain. What I'm going to refer to now is the maximum number of electrons that can be on each shell. So this is shell number 1. So this is our first shell. This is shell number 2. This is shell number 3. All shell number 1, so the first shell, can have a maximum of 2 electrons on it at one time. So shell number 1 contains a maximum of 2 electrons. Shell number 2 has a maximum of 8 electrons. And we usually try to draw our electrons in pairs. So when we draw 8 electrons, we go 1, 2, 3, 4, 5, 6, 7, 8. So notice shell number 2 has 8 electrons, and that's a maximum. Doesn't mean it always has 8, but it can hold a maximum of 8 electrons in it. And the same with shell number 3. It also can contain a maximum of 8 electrons. And we depict that again by drawing our electrons in pairs in the shell over here. And in this nucleus, we will write down how many protons and how many neutrons are in the shell. Are in the nucleus of the atom. So, when we draw our Bohr-Rutherford, what we have to represent is the nucleus, which has the proton and the neutron. Then we also have to draw the shells. Now, we are going to talk about how do we know how many shells each atom should have. And we're going to talk about that. But I want you to know the rules regarding the shells. That shell number 1 can only have a maximum of 2 electrons. Shell number 2 can have a maximum of 8 electrons. And shell number 3 can have a maximum of 8 electrons. Those are the rules regarding Bohr-Rutherford, and in the next video, we're going to be talking about how do we draw the Bohr-Rutherford for a specific element in the periodic table.